Thanks for joining us in person, and also thanks to everyone who's joined us online and in Hobart. I understand that there's also a group gathering at Skyro there. So welcome. I'll start off by acknowledging the traditional owners of the land that we're meeting on today, those of the Wurundjeri people and the Bunurong people of the Kulin Nation. They've been custodians of this land for thousands of years, and we'd like to acknowledge and pay our respects to their elders past and present. We'd also like to extend our welcome to the acknowledgement to the traditional owners of the lands of the people that are on our live stream are joining from across the country. So to start off by introducing you to our Stat Society Victorian and Tasmanian Council. So you might notice a few council members, maybe council members in the room give a wave. If you get a chance to chat to them after the seminar, it's always a good thing. We're always happy to talk to other people who are interested in stats and data science. So I'll go through a few announcements and then I'll introduce our speaker for today. So first, just some contact details for the Victorian and Tasmanian branch. If you'd like to get in touch, we've got email, we've got Twitter, we've got a meetup you can join. We also have an amazing t-shirt designed by our president, Ben Harrop, which you can buy, and all the proceeds go to support early career researchers. Next announcement, the Equity, Diversity and Inclusion Committee is looking for members. So if you're enthusiastic about that, we'd love for you to join. You can scan the QR code if you like, or contact directly Jess Kazza at her email address on the slide. Some upcoming events. So we've got in September, our September event will be an early career showcase. That'll be, we've got someone to go on mute. Ian Hunt, if you could go on mute, that would be great. So that'll be both in person and online. Details will be on our website once we've got that organised. And then our October event is the Belts Lecture, and our co-organiser here, Professor Inge Koch, will be speaking for that. So we're really looking forward. That's our premier event of the year, and will be followed by a dinner afterwards. So highly recommend you join us for that. Please save the date. We wanted to say congratulations to the 6 recipients of our funding for the Australian Statistical Conference, which is happening in Wollongong this year in December. So we'll be excited to see you there. And also a reminder for anyone else who hasn't heard of the conference yet that registration is open. And then, of course, a plug for the Stat Society. So if you'd like to support the Society, if you're a student, membership is only $20, which is quite a bargain. And then we have various memberships for early career researchers and later career statisticians as well. Advertisement of the Di Cook Award. So that is for students who are in Victoria or Tasmania and have developed open source statistical software. So if that's you, please do apply for the award. We have a Stat Society Slack. So any questions, if you're joining the seminar online, please go to our Slack page. There is a post there in the events. And if you post any questions you have about the talk, then Patrick in the room here will relay those to the speaker. You can also use the Slack for getting in touch with other statisticians in the community. For those of us in Melbourne, we're planning to go to dinner afterwards. So this is my reminder to ask people to raise their hands if they're planning to join for dinner so I can take a count. Great. I will remember that. Okay, and after the many announcements, thank you for still being here. I'd like to introduce our speaker, Dr. Zili Zhu from the CSIRO. He's part of Data 61 and he's a director of the Risk Lab. We're really excited to have Zili here today. Before I bring Zili up, I wanted to thank my fellow council members, Patrick, Alan and Ben, for helping organise this event. And a special thanks as well to Professor Inge Koch and to RMIT for hosting this event here in person. So that's enough of me. Please welcome Silly up to give his talk.
Thanks for that, Alina. Thanks for that. Thanks, Alina, for organizing the event and the invitation to give the talk about what we have done, some of the projects in the risk lab within CSR. I was wondering about your name of your land compared with Alina. She here? She's not. So I don't need to repeat it. So I'll go down the next one. Okay. So so the risk lab, to give you the overview of what risk lab is. And of course, our title here is about seeking value in uncertainty. Normally people say uncertainty is bad. So our view is that uncertainty is good. It's all about how you get value out of it. So this is kind of the focus of what we do. And so the risk lab is actually a global kind of network of risk labs. So we got 5 other risk labs around the country, around the world. And there's no kind of legal obligation from each party to do anything. It's more kind of, for example, if tomorrow you want to go to Europe somewhere, you say, okay, why don't I go to the risk lab, have a look, see what they are doing. So, for example, I went to visit, I was saying earlier, Justin, to Munich to visit risk lab at Allianz. Fortunately or unfortunately, the risk lab at Allianz has become very commercial. It's basically is owned by Allianz, and others are very academic. So it's quite a good system in, and to be honest, in other ways, also give you kind of a virtual kind of center focus. So people say, okay, risk lab, we know what you do. So we do have 8 industry advisory board members. Essentially, we have annual meetings. They can come and tell us what I think you should do. And so we get advice from them if we need anything. We have what's called the industry affiliates. And this is actually quite a good system in my view. We have people who actually retire, like work in the industry. And they actually are very keen to be part of whatever is going on in the kind of academic world. And I highly recommend the system, not only for CSRO, but also for any universities, to basically leverage their expertise or the wisdom they acquired in their own whole working life. And now they are actually very happy to help anyone. And it is really a shame to waste that, in my view. And especially in an aging society, it's not about just to utilize anybody, it's really getting the help, which a lot of young people don't have. And so anyway, so that's what we're trying to utilize. And we have interns from Monash, mainly from the Monash Financial Math Master Program. And we mainly cater for that. But the demand for interns are extremely high. And so it's apart from that, it's actually very good for students to know that they have an intern program. And that'll be a drawing card for any university. So we're sitting here at RMIT. I can highly recommend if you say, okay, our program can find you internship with the industry. I'm sure you get more students coming, or you can increase your fees higher too on top of that. And so anyway, so I think Risk Lab is in my view, is a fantastic virtual center, and it's even for CSRO. And people say, oh, CSR, what does this stand for? Nobody knows in overseas, but they know what Risk Lab stands for. Anyway, that's enough PR for the talk. So what you ask, what do we normally do in Risk Lab? Just give you some general ideas of, sorry, I'm just thinking, because I'm pointing at the screen. I know people on the web, they don't see that. Yeah, anyway. So generally, we have statistics. That's why we are here. And applied math is another one. And so that's the main kind of bread and butter we have as the capabilities. That's the standard stuff. However, obviously we expand into financial maths. That's very important. I think my view is that it's not just another discipline. It's actually something you could leverage. If you say, oh, I'm in statistics, I'm in applied maths, it's the kind of traditional stuff. But nowadays, it's multidisciplinary, financial reward of the calculation of the risk. You need to include the benefit and the cost. So that's why financial maths becomes actually quite important part of a discipline to leverage. And another one I was trying to say is software engineering. Why? Because when we do work, especially for industry, just having a report is not enough. Just say, oh, I think I can formulate your problem statistically in this way. It's more kind of you need to have a product. I need to have a solution, not just a report. The solution means that it's a software in our form, software deliverables. Then your client can take it and run on their own computer. They can actually run it without you. That's very important. And that's why I focus on this software engineering. I think a CSO is basically trying to focus on that, but I'm not saying it's doing a good job. But I suppose under our control, we're trying to do a good job in that sense. Okay, so going down, I'll give you two examples as a kind of prototype product. The left-hand side is what's called a option pricing system we developed. That's called the Redditus. This actually used as a plugin to a commercial operation based a company based in UK. So this is called Phoenix. They have a 350 institutional clients around the world, and they run this option trading system for foreign exchanges. They every day around the world, and our plugin is called CSR plugin as a product plug into their system. So we obviously we are not a commercial operation. We only focus on very narrow component of any industrial process, if you think in that way. So basically here in this industrial process, we provide this plug-in software. They can rely on that to price their exotic options. So of course they can develop their own, but like any industry like PHP, they can develop their own, but they are not good at certain things. And supposedly our academics or half academics like CSRO, we can provide something they don't have. And so that's the kind of partnership. Another one here is we developed this actuary model for forecasting superannuation incomes, mainly trying to help people to guide them in terms of how do I consume my super, now I'm retired. I have $1 million. What's the best way of using the money? It's actually very topical today in Australia. Right? How do you use 4%? Or do you take maximum, minimum kind of jumping around depending on how the market? It's quite important. Why? Because two risks. One is people don't know how long they're going to live. Well, obviously, the longer the better. The problem is that do you have enough money to cater if you live to 120 years old? That's one. The second is that what about the market? If the market goes well, that's great. But what if the market goes down? I take 5% each year. It's still good enough or not? So that's the issue. And unfortunately, in the society, the problem is that people, because they don't know, they use minimum amount of money, and which is the problem. It's like people are living in poverty when they have $1 million in the bank. So it's really not good use of superannuation money. And also then they pass the money when they die, they pass it to their children. And it's not a good system for superannuation, becomes a wealth generation for next generation. You know what I mean? So anyway, so that's why we did work there. So, okay, and move on to this model. It's called actuaries model based on Wilkie's model from UK. I'm not trying to explain to you how this whole thing works. Just give you some idea, right? So essentially you're trying to forecast the economic system, what's going to happen in the next 20, 30 years. And here is like you're using inflation as the driving force, and which is in the middle, it drives the house price, it drives equity returns, dividend, and also it drives interest rate. So that's obviously today is very relevant. And then, so this is called a cascading system. It's like from inflation, you cascade to equity return, dividends, and then goes to short-term interest rate. This is according to Wilkie as an econometrician or economist as a kind of common wisdom. I'll show you later. It's like if you use machine learning, maybe that's not true. And when I say not true, it's like you use data to distill the system rather than using the economist brain. Okay, so if you want to do lots of math, this is the kind of equations you're talking about. But we're not going to go through that. But essentially, the cascading relationship is you put something in the right-hand side, driving the variables on the left-hand side. It's basically like the regression model, right? With some noise is coming. So then you train the model on the historical data. And then you can form all sorts of equations there. I don't want to spend time on that. And so what we have done is using that equations, calibrate to the historical data, like short-term interest rate, long-term interest, everything. And then we do the forecasting into the future. So if you look at for example, CPI and or the wage index, wage inflation, long-term interest rate, everything can do. You can forecast. I have to admit to you that you can forecast a blob of 1 million possible scenarios. And the question is that, okay, what are you going to do about it? So I can tell you, typically what we do is like you can say, okay, I invest say $100,000 in the beginning, and then I contribute to it every year 10,000, as a return, as superannuation, and then I can get a rough expected value. By the time I reach 65, this is $1 million, for example. So you can do that. So I have to admit that that's not satisfactory. Nowadays, people say, okay, so what? So you get rough general estimate. I think we have actuaries sitting here, obviously disagree with me, which is fine. So that's what actuaries do. They provide, okay, roughly this is what happens. But I think in the general, this is what moving into what's called robo-advice. Not a robo-debt, by the way. So this is what we're talking about AI, the machine learning.
CSI, right?
Sorry? Somebody's asking a question? Yeah, okay, I'll keep going. Just ask again. I didn't catch it, sorry. So in a robo-advice, essentially all the superannuation companies are moving into is that because you can't afford to see a financial planner, which can cost $7,000, can I get a robo-advice to get a rough idea what's my best approach going forward with my super? So this is where it plays into. Is how do you actually use a forecasting model, give you rough advice, and then you can, once you fine tune your strategies, then you can see a financial planner. Then you can reduce the time you spend on financial planner, save money. So that's where I think it's going. And anyway, so that's basically the industry is going. I think it's we were talking about earlier about AI, right? Become so fashionable or popular. I think this is where the AI kind of stuff, digitalization, I don't like using AI, and it can help. And it's the right time to come in at the right place. And I'll show this slide, just give you an idea. We do go through the standard statistic analysis, as to are the models, the residuals independent or not, that can go for standard treatment and for different variables and to see. So that's where we stopped. Okay, so this is now we're working on, remember the model I showed you before? Now we're trying to use what's called graphical model, network model, to see instead of using the economist's brain to formulate the model, can we actually use large data to automatically generate the model? And so this is not just for this application, for the Wilkie model or super model we have here. It's more, later I'll show you how do we For example, if somebody want to know, I want to invest in, say, a copper mine or an iron ore mine, which one should I choose? That's a major decision to make. The issue is that when you make a decision today, it can't change for the next 10 years. Right? The transaction cost is very high. And so this is where we're talking about is how do you actually look at all the economic variables, like a copper price, whatever variables, and just process all the data. And automatically comes up, say, okay, my copper price is mainly dominated by X, Y, Z, instead of some guy sitting in the office thinking, oh, I think it's dominated by ABC. Right? So this is where we're coming from. Anyway, so this is called a graphical model, a network. So we automatically prune it. So basically, you say, okay, for example, the model we have here, we have 14 variables. They're all linked. How do they relate to each other? Nobody knows, assuming we don't know. So they have a full matrix here. We call it the adjacent matrix. And then you form a kind of network, each one driving the next. You automatically assume everything's related. And then you use the pruning network to reduce the full matrix into a sparse matrix. That's it. You can't see it very clearly. So you see the big major numbers, you will see that very clearly. So I'll go to the next slide to give you some idea. So it's the same thing. So we tabulated it. It's like, essentially, it's like saying, okay, you have a full matrix. You're trying to use machine learning to reduce the connectivity of the full matrix. And so how do you do that? You by monitoring the forecasting accuracy according to your pruned network or pruned metrics, the full metrics, reduce it. Of course, you can reduce to very, very, like say, you have full metrics, you reduce to 10% left. Then that means your error might reduce, goes up. So if you look at it here, for example, we want to look at CPI as the target, and which other variables are important to reduce the, which other variables can be used to predict the CPI. And of course, you can use 100%, which is full metrics, but you can reduce that. So slowly, for example, this case, we 29.12% kind of sparsity, which gives you kind of roughly the best error and also reduce the connectivity. So essentially, you get short-term interest rate here, and then you get 0.44 as a, if you just imagine it's like a linear regression coefficient as the importance, right? And then you get a domestic asset price is equity price, right? And that's the tool to drive it. So there's different way of doing it, and I suppose your question is that good? It's like any machine learning, you have target error measurement utility function, right? And you're trying to minimize the risk, so minimize error. At the same time, you're trying to see, can I really produce something meaningful? And if it doesn't work, or if it works, is that true or not? It's not you can say. But anyway, so that's how, I suppose what I'm trying to get is that you can see the connective, like a CPI is linked by the equity price here, and also by the short-term interest rate. So so the data does justify some of that, but doesn't reproduce it. And but we don't have to reproduce it anyway. The issue is that if you use it, does it work? Okay, so we're going down a little bit further along the same line. It's like, okay, for example, here we have a CPI growth rate. Should we actually look at this is using machine learning again? Is look at the historical patterns. Can we produce clusters of four clusters for each economic variable which happened in the past? So that's essentially, if you see that. So here, the first one is the CPI, and the short-term interest rate, another unemployment benefit rate, and another one is the housing price, and the last one is the variance. That's the variance we produced. Anyway, so if you look at the three variables, short-term interest rate, they have the like flat or going up or going down. And then what we're trying to do is that, do we actually find the correspond, let's say, the second cluster. If you look at the interest rate going down roughly, does it associate with CPI going up or going down? So that's what we're trying to find, the correlation in terms of if this pattern happens, if the interest is going, for example, this one, the last one, first going up, then comes down. Does this, oh God, this is, can I go down here? It does work. Does it associate with, for example, here, the unemployment rate going up? So you could see that initially the unemployment rate is low, but then obviously the interest is ranked up. But once it's gone up, then realize the unemployment is still going up. They start to reduce it, but the unemployment rate is still keep going. So you could see the correlation there. So that can offer you some valuable insights. So that's the last one on this topic, which is to say that, okay, we have a clustering for the historical patterns. How can we use the historical patterns to reproduce it for the future? Essentially say, okay, for this example is we want to predict copper price, not for the next 1 year, for the next 20 years, for example. That's the example I showed. Sorry, yeah.
What are 4 clusters that you said?
Clusters?
What are 4 clusters that you mentioned? Why you would consider 4 clusters?
Well, it can be 6, it can be 2. It's more using the evaluation to see, because in the normal kind of clustering, you can have 4 from 1 all the way to 100, for example. You want to see where the arrow flat plateaus. That's like where you stop. You don't need to go more. Essentially, the clusters give you the typical pattern. Like say we
are scenario based. Example for worst case scenario and this case, or
no, for the cluster is actually for historical really happened patterns. So it's not a worst or best scenario. It's like saying, okay, let me look at the 1960 to 1965 time period. What does it look like in the interest rate, for example? And then you look at for 5 years period, can you give me all the typical patterns for 5-year data in the past, in the history happened? So it might come as, okay, I think that you got 3 typical patterns. And they look like, for example, this one, that one, that one.
ascending, descending, or
Correct, yeah. So you don't decide on that.
The gray line is the real data,
No, the solid line is actually the median value.
and the gray is the real? Or?
The real one, correct. Okay. Yeah. I'll go back here. So essentially, you can use the clusters to say, okay, you can use a linear regression, for example. So, okay, let's assume what happened is the cluster is going to happen again for the next 5 years. So I just drag the 5-year pattern, which is typical like a cluster 1. That's the one I'm going to use for the next 5 years. Then you ask question, is that correct or not? Nobody knows, obviously. Right? Anyway, so that's what we have done. So you get, for example, we use oil price and also using Hang Seng index. We have historical patterns of Hang Seng index and the historical patterns of oil price in the past 20 years. And then we find the typical 4 clusters for each variable. And then we just rotate through the 4 clusters. 4 times 4 is 16. So you generate 16 scenarios for the future. Right? So you can make it more sophisticated, like, okay, you find a 5-year cluster. Maybe the cluster doesn't start from year 0. It starts from year 2, for example, depending on how you choose that. Anyway, that's you can do a lot of work there. So for example, here, just give you an example. Is okay, we use starting from 0, we have 16 possible scenarios. And then this is the backtesting results, like the blue one is really what happened. If you go slides back to 2021, right, until 2023, that's what we predicted as scenarios and what really happened. And then I suppose you ask the question, what are you trying to achieve here? I suppose if you go to for example, mining companies, that's the question they will ask you. Tell me what's going to happen for the next 20 years. And we tried very hard. I have to be honest. Nobody knows what's going to happen next 20 years. The question is that they actually do just put their head, think, okay, I think the next 20 years is going to be $1,000 per ton, for example, right? And they would just go ahead and do it. And because they are the CEOs, so they decide that's the case. And so I suppose what we're trying to do is provide a more repeatable, quantifiable kind of platform for them so that they can say, okay, I guess it's $1,000 per ton, but let's just see what you think. That's essentially what we're trying to do here, is give them a platform to do some quantitative analysis, because we don't think you can actually forecast next 20 years anyway. But it's better than nothing. It's an improvement. As long as it's improvement, it's good enough. And another thing we're trying to do now is with all the fuss about the machine learning or chat GDP, right? What we're trying to do is, okay, let's actually link the clusters into the future back into the cluster in the past. What happens is that we can actually find all the clusters, what happened in the past years. For example, you can say, okay, for cluster 4, it happened in 2008 and 2009, and also happened in 2012 and 2014 for cluster 4, and also happened in 2022. So that seems to be financial crisis, the market crash around 2012, and that's the European, nearly gone bankrupt there, and also obviously the pandemic. So what we are planning to do is we can link this using chat GDP to straight into the cluster here. So if the people say, okay, I want to look at scenario number 7, what does it correspond to historical occurrences? Right? It might tell you, oh, that was the financial crisis. So anyway, so that's how we're trying to present as a product, if you think it. Anyway, anybody can ask questions, interrupt me. Oh, welcome.
Is this for sale?
Sorry?
Is this for sale, like other future scenarios?
It's not a commercial, by the way. We're trying to, yeah, that's right. We're trying to engage with the mining companies for that. Yeah. Okay. So this is going to the derivative valuation. I'm not trying to give you an option pricing.
Sorry,
Yeah.
I do have a question. You said it's better than nothing.
Yeah.
Is it? You're predicting that far into the future,
Yeah.
and you're the CEO of a mining company,
Yeah.
and you're really confident because you've got this 20-year prediction. You're potentially very confidently incorrect
Yeah.
in the decisions you're making about the finances of your company. Is that better than not knowing anything?
Well, the thing, so as I say, normally what you do is this, okay, because today's price is like $35. You think, okay, in the next 10, 20 years, I think as long as $40 per ton, we'll be fine. So they just use $40 per ton. I'm not making up. This is basically how they do it. They don't use like the variable ones. They just said $40. Obviously, $40 is wrong, right? But just the number. So if they're above $40, they say, oh, great, we are in the money. If it's $36, then okay, maybe it's not good. That's essentially how they do it. Okay, so what we're trying to do here is like we given the historical data, that's roughly the possible scenarios. That's the major consulting companies do that now. It's all the scenarios. We'll give you a scenario. And I think our view is the scenario is all wrong too. And our scenario here is also wrong. I agree on that.
I guess it's better than just throwing a dart at a board and picking up.
Correct, yeah. But and then there's another one, which is the second step, which is throwing a dart. Obviously, you can't do any analysis. Right? So this one is you can say this is actually we have done is to say let's assume in 2 years' time there will be a disruption, and my price is going to drop by 15% on oil, for example. Tell me what's the corresponding change in copper price. right? So that tool will give you that value, more kind of almost like a sensitivity analysis. Right? So instead of giving you say the absolute value is right, you say absolute value is wrong, but the sensitivity analysis is correct. You see what I'm saying?
Yeah,
Right?
yeah. Cool, thank you.
We come down to I'll give you the generic option pricing before I go to details. Essentially, before I just say option pricing, some people might not know what it is. Right? It's like you can buy BHP share price today for $46, but I don't want to pay for it. I say I want to buy it in 1 year's time for $50 per share. And but if the price is still 46, I'm not going to buy it. But if it's 52, I'm going to buy it. But if it's 52, I will buy it at $50. So that means I'm going to make $2. So in that sense, if I buy this product, the option, I will never lose money. I can only make money. Obviously, that's too good to be true, right? So you need to pay me something today. And that's what the option pricing is about, is say how much you need to pay me today to have the privilege to always never lose money in 1 year's time. So the underlying process normally is using X stop price, is a typical Brownian motion, right? Everybody knows that. And since we are in the statistical society here. And then after you do all this, what's called a hedging principle, essentially it's like as a bank, I can sell this option. You think, oh, I'm just betting against the bank. Actually, the bank doesn't actually bet. They actually hedge the risk by buy a little bit of BHP share. So if the BHP share goes up, they buy a little bit more. But if the BHP shares goes down, they sell a little bit. So anyway, so by the time they reach the 1 year, doesn't matter if the price is above 52 or 53, the bank will never lose any money. They just pass on the share to you, right? So you are happy, you say, oh, I made some money. Actually, the bank didn't lose, just take the fee, right? Because you pay the fee already. And then the fee is used to hedge the risk in the market. So people always hate banks. I always say, like, banks just taking a transaction cost, and they are not the enemies. The enemies are actually the market. Essentially, you are betting against the market, and who is on the market? Everybody's in the market. And anyway, so when you do all the hedging, finally you get this partial differentiation equation. It's called Black-Scholes equation. And you solve that equation, you get the price. And so anyway, this is the graphics talking about times here, 1 year. Today's asset price is like $10, like another example. It can go anywhere. I'm just saying that I buy the option, the strike price is $11. In 1 year's time, I pay you $11. If the price goes up, I take the excess. But if price goes down, I don't even buy it. I don't lose anything. So that's how the option is. You need to pay a premium today to buy an option. But the reason why I show you this graph here, the zigzag in the final element mesh, is that that's how we got started from CSR. And we were trying to make some living. In CSR, we need to have 50% of our income coming from the industry to show that if you don't have 50% of your income coming in, the CSR say, okay, your research is useless. Right? If somebody paying you for your research, that means your research is useful. You can say it's fair or not fair. In my view, it's fair, right? And anyways, that's the principle of CSR. Is our research needs to be adopted by the industry. And if nobody adopting it by not paying you, that means your research should be closed down. And so we were trying to have a partial PDE solver. We think this is fantastic, it's going to save the world. We're trying to sell to BHP. BHP, I don't even want to pay you $20,000. Right? Obviously, it doesn't cover our salary. And we said, what can we do? Option pricing. We have this fantastic tool in engineering. We can solve any options. Right? So if you look at this graph, you can think about these boundaries. Like any boundary shape, boundary condition, we can deal with it. So we presented this to CBI, to NAB. They look at, oh, that's fantastic. We'll pay you 60,000, not 20,000. And that's how we got started. Anyway, that was not joke, by the way. It was actually like how we moved from engineering into financial market, because it's easier to quantify the value adding. And also, another easier thing is that in financial market, because it changes all the time. So the equation changes all the time. So that they always need people who be able to solve new equations. So that's fantastic for us. It's like that's our job, to solve new equations, because once the old equations solved, you don't need to solve it anymore. Right? Anyway, so coming down to this equation, this is much more sophisticated equation than the Brownian motion. Right? That's called the stochastic dynamic. Sorry, it's called the local stochastic volatility model. It's instead of one dimension, it's actually had a two dimension. You have S spot price. It's called drift term, right, log normal. Then you have this volatility sigma, but this sigma itself is also a volatility random. So you got the equation for the volatility, and then of course volatility has its own volatility, right? So it's all very elaborate, and of course normally people in academic sorry, just looking at my time. Oh, God, time flies. In academics, think, oh, let's make an equation even more complicated. Right? And there's a catch. I'll show you what the catch is. Anyway, so for this sophisticated equation, it's only two dimensional, not that sophisticated. You can convert it using into another two-dimensional PDE. You can solve it, and then you get your option price. And that's how this is actually the latest, I would say, the most widely adopted model in the financial market around the world. And so that's how we developed that model too. So Goldman Sachs have that as well. But if you don't have that model, you can't do anything. Okay, so I just come down to the question. The problem with the sophisticated models that you need to calibrate it. Often people say, oh, calibration is easy. The calibration is actually not easy in financial market because it's not looking at the calibration to historical data. It's calibration on today's traded market price. So if you look at it, like say this one is the vanilla price for all the options traded on the market. There's a spot price, different strike, if you think it that way. There's a time maturity. For different strike, different time, there's different market traded today, very liquid. So the question is that your model needs to reproduce this market data. If you can't reproduce it, then the model is useless because somebody pushed the button, get a wrong different price, then you'll be hedged or you've been taken advantage of by the market. So because that's not, it's like you buy a house, it's the house price is 1 million, and you say, oh, it's 1.2 million, then they just, okay, I'll sell to you. But if it's 800, you think it's 800, you'll never have a deal. So that's why you need to reproduce the market. Then you'll be able to price options which are not traded on the market, which we call the exotic prices. Right? There's certain option tailored for specific needs. That's not liquid, it's not traded on the market. So you go to NAB, they'll give you one particular option. There's a big spread on the price. So the model needs to be calibrated to the market, but then it needs to reproduce the market price also for the exotics, not too far away. So that's why I'm saying the challenge in option pricing is always, first, it needs to be calibrated. When we say calibrated, it can't be 1 hour. It normally needs to be within seconds to be calibrated. And then it needs to be able to be pricing something within 1 second. Not only just on the trading, like you push the button, get a one price, right? But also they have thousands of options on the books. You know, NAB would have thousands on one book, right? And so every day they need to reprice the 1,000 deals. So just imagine if each one takes 4 seconds, how long is it going to take for the thousands? Anyway, so that's the challenge in that area. I'll just go very fast now. So then your question is like, what the hell CSO does financial market stuff? It shouldn't be doing that. Well, I'm telling you that actually we do things more than that. So we developed the option pricing technologies, and then we actually, guess what, developing a water options market for Australia. So if you look at it here, this is the market in different trading zones of the Murray-Darling Basin, right? They have different prices. And essentially at the time, that was 2000, I think, 17. And the market is always spot price. So we offer them to do an option market on the spot price. And I'll go a little bit faster now. So for the statisticians here, you can see the market, quite funny. The transaction cost each day can be from 0 price to thousands price. When you average the prices, it could be $100 per megaliter, right? But the traded price could be 0, or could be $7,000 per megaliter. Now your question is, what the hell is going on? What happens is that they have related party transactions. There might be brothers and sisters selling to each other, for tax purposes or whatever. We don't know. So that's why you have, for each day, you have prices ranging from 0 to very high. So if you do a volume weighted medium, that's what you do every day. So it's very jumping around quite a lot. So we developed a model, the log normal mean reverting model for them. And then so we kind of smooth them out into something like this. And then we fit that to a log normal mean reversion model, and then use that model to produce a price. So we developed that as a software into their trading system. So then they can, on the water options market, you can say, okay, I want to buy 1 megaliter price for whatever price, but I also can buy options on the water rights. So that's a useful thing to do for the. Oh God. So I think sorry, I'm just looking at time. Yeah. So that was quite a good application and a good use of, I suppose, expertise in Australia. Okay, we'll move on to another one, which is using machine learning or statistical means to kind of predicting the nature of the high frequency trading data. The example here is about a hedge fund in US. What they want to do is it's like a nanosecond trading coming in the market. We actually don't know what market it is in because they make all the data. You never know what it is. They transform the data so that they hide from us. So of course we are paid to do the work. So what happens is that they want to use any statistical means to identify who is the market maker in the market. And I'll just give you some example. So essentially the top one is the blue line is the market. It's traded every I think nanoseconds. Can't remember the exact number, but anyway, so you can see exactly. So the red one is a trader. So they want to identify, is that a trader, a retailer, a fund manager, or a market maker in real time. So then they can change their trading strategy against a person. And so this is using different machine learning techniques. I think this logistical regression model, we're trying to predict, given the features you identified, what's probability is going to become a market maker. So this looks like it is a market maker. So the probability goes up. And sorry, this is using logistical regression model to predict. That's again, you can see the blue line is the market, the transacted price. The red line is the price from this player. Obviously it's jumping around, always hugging the price, but not transacting. So that's a typical market maker. So using logistical regression, you can identify this one, but obviously it doesn't always work. So for example, here, we find that the red line in the bottom section, this logistical regression's probability forecast. The red line will say, okay, it is a market maker. But then suddenly it changed. So then it comes back. Okay, so I'll move on to the next one. This is more about the early warning system. And so this is for a regulator. Essentially, they want to find out some in the market, the fund managers. They say, oh, I'm investing in you. Yeah. I'm investing for you in the fixed income, which is very stable, or in equity, which is very high return, but high volatility. So they might be telling you the lies. So the regulator is trying to find out, are they actually abnormal or not? So that's the task. And I think I jump here. So we have data for complaints from the investors about their own fund managers, right? So that's giving you certain data points, and then we can have a control chart on that. Anyway, the reason I'll try to show you this one is that it's not just do analysis, produce results, give you report. It's more about, can we give you a system where you can actually play by yourself without us? That is generally our standard. So this is using a funnel chart to show within a month how the volatility changes, the returns goes in that funnel chart. It's quite well, I have to say, it's quite a simple statistics, but unfortunately, in reality, people want simple. Simple is better than more complicated. So this is use the exponential weighted moving average to identify the returns, to identify anything above or below the right line is regarded abnormal, or so we can further detection. Otherwise, what they normally do, they actually go through each company, depending on the complaint. They say, okay, let me go have a look. So what we're trying to do is, how do you automate the system? So that's essentially another control chart. Is looking at the volatility for this particular user, so particular fund manager. Volatility is constant. I think this actually hasn't started, and then drops, and see where is the abnormal time period. That's from 2017. Okay, so that's the system we developed for them. Essentially, depending on what you pick, the monitoring, configuration, prediction, and then you can choose that and then find out which one is come up as have confidence at high level is abnormal or not. Okay, I think I come to the end. So I have tried not to be too technical in terms of the details, more kind of give you a flavor of what we normally do. And so the idea was always say that it's quite a multidisciplinary in risk lab. It's not like a statistics or applied math or whatever. It's more about the solutions. And another one is what we're trying to say is more focused on a deliverable as a prototype product or software rather than a report. That's always our belief that that's how the clients need that, because nobody even have time to read the report. And what they want is like, okay, report is useful to give you as a manual, but the deliverable should be a software which they can go back home and run on their own computer. Lastly, before I go, is we talked about it earlier, is talking about AI, right? I have my own personal views about AI. I think AI, as what they're talking about, it is actually quite useful, particularly with the service sector. But I don't think it's actually useful for example, manufacturing. We're talking about Industry 4.0, and it's like I always say, Industry 4.0 is not for manufacturing. It is actually for service industry, which is happening now. That's why it's making such a huge impact. Why? Because it impacts everybody's life. Whereas Industry 4.0, which actually happened 20 years ago in the factories, which we don't go into, we don't even look at it. You know, they're manufacturing cars automatically, and they don't need us to be there anyway. So I think it is actually very, very useful, right, in terms of for statisticians, because as an engineer myself, I think statistical work generally produce probability. In manufacturing, you don't need probability. You actually precision manufacture something, yes or no. There's no such thing as 90%. Right? Whereas in the service industry, you do have 90%. For example, I give you a loan, I can be wrong 90% of the time or not. Right? It doesn't matter. But in manufacturing, you can't have that. Anyway, what I'm trying to say is that I think it is actually very useful. But as AI, I don't think AI exists. It's only digitalization is what's happening. Back to you. Thanks.
Talk. It's amazing to see how many different areas you can apply your work to. So should we start from questions in the room? See if anyone here has any questions for our speaker?
From the beginning, you were talking about the robo advice for like super planning and that sort of thing in a way to enable end users that don't have several $1,000s to pay a financial advisor to get financial advice. Have you actually trialed that with users and understood how they use the tool and interpret what it's telling them? Because I feel like people that don't necessarily understand the statistical underpinnings of what you're showing them might have a different perception of, say, what risk is or what a proportion is. That
Yeah, that's a very good question in the sense that it's true. Ordinary people on the street, they don't understand. Even if you're talking about risk, it's like, what the hell is that? So the point is that they generally use robot advice, the software, almost like educating themselves. To say, oh, it's like before you see a financial advisor, right? Normally, it's like you spend the first 2 hours talking about basic stuff, complete waste of money. But a robot advice as a software, essentially like taking over that part. So then people say, oh, I can see what's going on. Obviously, they don't understand it, but it's still educating them. And then by the time they reach to the financial advisor stage, they already equipped themselves with a certain jargons. So that's very useful.
Yeah, Patrick, should we see if there's
There's nothing on Slack, but personally, I've got one. If we're interested in sort of learning more about these projects, is the software accessible on the web, or is it just a collaboration with an industrial partner?
So some software, I think the supermodel, you can go online, it is online. So you can put things, you can change it, it gives you results. So that's on the web, available. To be honest, it's like a PR, right? But at the same time, of course, we don't give the software free out. When I say free means that anybody can just take it. It's more kind of we trying to use software as a kind of as a base, and then engage with the clients to adapt it to whatever clients needs. So for universities, of course, we haven't done that before. We could say, look, the universities, we can use that to teach students as kind of example software to show you how do you project in the future, right? But we need to come to arrangement for that kind of service. But otherwise, obviously, we are happy for it to be used as the first thing. Second is make a profit out of that too. But because for doing all the support, the further development, obviously you need a lot of resources. Yeah.
Great.
You mentioned earlier that 50% of your funding has to come from industry.
Yeah.
Do you go out to industry to get new problems, or you've shown us quite a number of different problems you're working on?
Yeah.
Does industry now come to you because they have, for some reason, also have heard how successful you are in some areas, or what's the sort of percentage of new customers that actually come looking to you rather than you going to approach them?
Yeah, I have to say, normally is well, we have business development people. They do go out, finding out the information. We do get an approach too, and generally is at least for me personally, is almost like always existing repeat clients, if you use that word, and you talk to with somebody, maybe like a conference like this, right? And that's I think that I'm interested in that. Then you keep talking. It's never okay. Let's do. I have this problem I need to solve. It's always like, I'm interested in that. Keep talking, and eventually develop into something both parties are comfortable with. So I want to use a repeat. That's new clients generally happens like that.
Yeah.
And but we have quite a lot of just repeat one, because once they start to think, you are reliable, they come back to see you again. Yeah. And also, I think it's a self-selecting process.
Yeah.
There will be clients who will never see you because they always do everything in-house. And there were the people who are very happy to go out. Yeah.
And how different are your models? You talked about the models for the mining industry.
Yeah.
Are you working with specific clients? And I'm not asking details, but is it more the mining industry as a whole, or is it more this client?
Specific, yeah. The mining companies are quite funny. They generally don't trust each other.
Of course not. Thanks.
I have a really naive question since this is really not my area. Like, you use a lot of examples regarding predicting the financial trading market, like try to predict the future. However, right now, because more and more so-called rare event occurs more and more often. For example, when Russia and Ukraine start war, more than 50% of the market value just disappeared in the crypto market. And also right now, the whole trade war between China and US just fuck up all the future stuff, like so ethically, like agriculture, etc. I'm just wondering, regarding modeling strategy, how do you control all those rare or usually rare events
yeah.
with
Yeah.
your model?
Well, so for example, the option pricing is quite relevant to what you're talking about.
Yeah.
So the one normally people propose is the jump diffusion model. The jump diffusion is you have one term in the equation, which has a jump is a probability, and the one is going to jump is another probability, right? So that obviously makes extra parameters you need to, as I said, calibrate. So anybody can produce a jump diffusion model. The point is that how do you get a jump diffusion model to reproduce what's traded in the market? That's actually very hard. Well, you can certainly do that. Then what the problem is that you can't be too different from the market, because if your model is like, oh, I can predict Russia is going to invade, back 5 years ago, right? Nobody will believe you. So then you wouldn't have a business anyway, right? So that's the issue. But so that's the market trading issue, right? But if you come into a mining company, that's exactly what they are looking at today. They say, okay, we are looking at what's going to become this rare mineral which is going to take over the world. Right? They're trying to find that. So obviously we say, oh, I can't tell you that because I don't know. Right? So nobody knows that. And so the only thing I think you can do is, okay, in our model, can we, that's what I said earlier, I can say, if you want to say it happens in 3 years' time, so suddenly there's a revolution or disruption, how it's going to change the, say, copper price. It goes up by 30% or drop down by 30%. Then the decision maker has to make that call. Say, okay, I will deal with that problem in my decision-making process. But nobody knows that.
So even though all those things are more like politics driven, not data driven.
Yeah.
Like
There's no data because it's the future, right?
Yeah. So like you do not have like a hard boundary or something within the model regarding prediction.
You can, well, I didn't show that slides where you do have a boundary, like say, I give you 90% on, right? So you just become wider. But how do I use it? You can't use it. It's like, yeah, sure, it covers all possibilities, but I want to make a decision today. Should I invest in hydrogen or not? That's the decision they're asking now. Is like, is it going to take off? That's the problem. Yeah.
Me? Yes. So the way you do your research projects, you're focused on developing these products, software. Are you also writing papers, or is it a different focus than in an academic context?
Yes, we are required. Well, not only we are required, but also obviously as a half academic. Now we want to write papers too, so we do write papers. Maybe not as many as you guys do in universities, right? But this is a dilemma because often, like you see, either it's very kind of industry focused, often it's very hard to publish. And for example, in actuaries journals, some actual journals are good because they are practical, and others like, oh, you don't have any new equations, like there's no publication, forget it. And so that's the dilemma we face.
We're already running a bit over time, so yeah. Sorry.
There's one more question in the chat, maybe, if someone has access to the chat. Read that out.
I don't see anything in the.
It's in the Teams chat.
Can anyone see my? Oh, there it is.
Where's my mouse?
Okay, question. Developing user-friendly, bug-free solution is a very time-intensive process. Do you deliver a polished software product to clients or demo a minimum viable product with a promise of a fully featured version at a later date?
Okay, answer that question. Yes, we do polished products. The one which we did we have done for the foreign exchange options market, that's very polished one. We have full version controls, everything. The good thing about that is, as I said, is a component wide. Also because you don't need to worry about the interface too much. You just plug into the back end if you think it that way. So you save a lot of energy in terms of designing the user interface. But it is polished in the sense that it has to work every day. And not only that, it's like if something goes wrong, like a bug is found, you need to respond within 24 hours because it's a global operation. So we do have that requirement. And so I think a CSR, even though I think it's better positioned than universities for delivering that, is still not good enough because, for example, delivering all this software, support, maintenance, version control, all everything is not regarded as highly research organization. So for promotion, everything, people don't get it. And how do you balance that? I don't know.
All right, we might leave it there with questions because we are already over time, but you can find Zilli online. I'm sure he'd be happy if you email him with more questions. And also if you're here, we'll go to dinner. I'm sure we'd love to continue the conversation there. So let's thank our speaker again for an amazing talk.